Welcome back to my channel. Good morning all of you. In the last class we have discussed about how to solve problems on relations. In this class, children, we are going to learn functions and different types of functions. I know that you are very familiar with the word functions since in your class 11 you have already studied what are functions. But anyhow, I would like to revise it again. So the definition is a relation F from a non-empty set A to a non-empty set B is said to be a function if every element of set A has one and only one image in set B. Okay, very simple definition. A relation F from non-empty set A to a non-empty set B is said to be a function if every element of set A has one and only one image in set B. For example, if I draw it pictorially, you can see that if I have a set A, if I have a set B, and if I have a relation between them R, for example, I have elements 1, 2, 3 in my set A, I have elements 4, 5 in set B, then the definition of function says that every element of set A, okay, every element of set A should have only one image in set B. Okay, every element of set A should have only one and only one image in set B. Very strong condition, one and only one image, right? So that means here you can see the children I have drawn here, 1 is going to 4, right? 1 has only one image 4, 2 is having 5 as image, 3 is also having 5 as image, no problem. 2 and 3 are different elements. Okay, different elements can have same image because it is not mentioned in the definition. It is mentioned that every element of your set A should have only one image. Okay, so when will be a relation not a function? Let us see. Suppose if I have a set A, I have a set B, I have a relation R. If I have an element here 1, 2, 3, if I have element here, see again 4 and 5. So here, if suppose element 1 is mapped to 1, again element 1 is mapped to 5. Okay, then what will happen? This will not become a function. Why? Because the element 1 has two images, right? You can see that element 1, if I map 2 here to 4, if I have map 3 here to 5, let us see now. Now what will happen here also? Now again you can see that children, here your element 1 is having two images, right? It is having 4 also as image, it is having 5 also as image, right? Even though 2 is also having image 4, 3 is also having image 5, no problem. But if you look at your element 1, children, it is having two images 4 and 5, which is not correct, right? Which is not technically correct, because when you solve a problem, an element cannot have two images, because you will have it cannot have more than one image, otherwise your calculations all will be wrong. That is technically wrong. That is what the function is, definition of function is emphasizing, that if every element of your set A should have only one image in your set B. And it is denoted by notation, you already know, it is denoted by F from A to B. So this is not a function, but this is a function. Okay, now we are going to define three terms. One is domain of your function, codomain of your function, and the third one is range of your function. Right. Now children, basically specific relations are functions, right? So all whatever we have learned in relations will be valid for functions. Okay, certain specific properties of relations, that one element has only one, such that every element has only one image, or one element is having only one image, that makes a relation a function, right? So relations, special character examples are functions. So whatever we have studied for relations is valid for functions. functions. So domain of f, as we have studied in relation, it is nothing but your set A. Codomain of f, it is nothing but your set B, and your range of f is the set of elements of B. Range of f is set of elements of B which are images of the elements of A. Okay, for example, let us come to the first example. You can see that in this example, this is a function. So domain of your f will be the set A. So it is 1, 2 and 3. Okay, so it is 1, 2 and 3. If I look at set B, it will be called as your codomain of f, and range of f happens to be set of elements of B which are the images of elements of A. That means 4 and 5 are the images of elements 1, 2 and 3, right? So in my range of f, my elements will come 4 and 5. Suppose children, if I add on an element 6 here, then what will happen? Now there will be a change, right? Now what will happen? Now here in range of f will have only elements 4 and 5, because what will happen is, why this is happening is because 4 and 5 are the only elements which are images of some elements in A, but 6 is not the image of any element of A, or in other words I can say 6 does not have a pre-image. So for in this case, your domain is going to be again 1, 2, 3, your range is going to be 4 and 5, but your codomain is going to be 4, 5, 6. Okay, now after this, two another types of function, not two another types of function, or two functions which we are going to use throughout the problem solving is real function. One is a real function and the second one is a real valued function. Okay, now what is a real function? Real function means that domain and range. Okay, real function means domain and range of a function is real number or a subset of R. Okay, so that means if the domain and range, okay, if the domain and the range of a function is set of real numbers or a subset, then it is called a real function. Now there is a small change in real function will give you a real valued function. Here it is having no condition on the domain. It is saying that if your range of a function is real numbers or is a set of real numbers or its subset, then it is called as a real valued function. Very simple. If domain and range of a function is set of real numbers or a subset of real number, then it is a real function. On the other hand, if the range of a real function, if the range of your relation function is a set of real numbers or real number subset, then the function is said to be a real valued function. Now children, you must have seen different examples of functions. You must have seen different examples of functions in your class level. Let us just see one or two. Okay, let us discuss about constant function, right? If I have a constant function, if you remember, constant function was, say, some f from R to R. Okay, from R to R, such that the function was defined by some f of x equal to some constant where c is belonging to some real number, right? C is a constant, c belongs to real number, right? So in this situation, what will happen? Is it a real function or a real valued function? Yes, it is going to be a real function because you can see the domain and the range. The c is also given to be R, so right? So it is going to be a real function, right? Then you must have seen, okay, here domain is, I have said domain is a real function. Your codomain is again a real number set, right? So what will be the range? What will be the range of this function f? Here the range, you can see that it is going to be only a single element, a singleton set C, right? Because all elements are mapped to C, or all elements are having images C. Now another example, let me discuss. You must have seen linear function, right? You must have seen linear function. Linear function, let me take from again R to R. So it will become a real function because the domain and range is again a real number set or its subset, right? So in general, linear function is written as fx equal to ax plus b. right? Linear function is written as fx is equal to x plus b, where a is not equal to 0, right? So what will happen? Here again the domain is going to be real number set. Your R is again going to be your codomain, and your range is going to be your values which your ax plus b is going to give me for different values of elements coming from the domain. Yes, so these were some just I discussed one or two function, constant and linear function. You must have learned, so we have seen so many functions, right? Sin x, cos x, tan x, these are all examples of functions, right? These all elements have, every element of the coming from the domain has only one image in your set B. Moving on. Now we are going to discuss different types of functions. Now there are three types of functions, children. First one is a one-one function. Second one is a onto function. The third one is a bijective function. These are the main things which we are going to handle in this entire lesson. One is one-one function. Second one is onto function, third one is bijective function. So before classifying them as these three types, the first thing is it should be a function. So let us discuss one by one. So let me discuss one-one function. Now one-one function is also called as injective function. Okay, it is also called as injective function. Now let me tell you what is the definition of your one-one function. Okay, so one-one function. So if I have a function f, suppose children, if I have a function f from x to y, this function is said to be 1-1. Okay, is said to be 1-1. You can write it like this also, is said to be 1-1, or this way 1-1. If for every x1, x2 belonging to capital X, f of x1 is equal to f of x2 will imply that x1 is equal to x2. Okay, so what is the definition here? F is a function from x to y is said to be 1-1 if for every x1, x2 belonging to x, f of x1 is equal to f of x2 will mean that x1 is equal to x2. That means if two elements have same images, that means the elements are same. Yes, so for example, if I draw it pictorially, children, you can see that if this is a function f and this is a function f, how your function should be. Suppose this is your x and if this is your y, every x1 coming from your x, every x2 coming from your x will have only one image. Okay, suppose this is my x1, this is my x2 and this is my x3. What will happen? Every x1 will have a unique y1, will have a unique y2 and so on. That means if two elements are having same images, okay, if two elements are having same images, then the definition strongly says that means the element should be the same. That means if you look at the figure, children, it means that if x1 and x2 are mapped to y1, then x1 should be same as x2. So this is the pictorial representation of a one-one function, or it is also called as an injective function. Now complementary to one-one function, so children, you can also have situations where two elements are mapped to one element, but the elements are different. Right, exactly opposite can happen without violating the definition of function. Two elements can have same image. For example, if I draw it pictorially, you can see that if I have a set A and if I have a set B, I can have elements of the type say x1, x2 and say x3, and here say element, I can have say element y1, y2 and y3. It can happen that x1 is having image y1, x2 is also having image y1, x3 is having image x3 is having image say y3. So here what is happening here, children? Here I can see that two elements x1 and x2 are having same image y1, but x1 is not equal to x2. This can also happen. So when this happens, right, when every element is not 1 1, see from the name itself you can see 1 here, 1 here, 1 here, 1 here, 1 here, 1 here, but here it is not like this. Here it is 2 1. Right, so such kind of functions where different elements have the same images, they are called as many one functions. So complementary to 1 1 function, we have many one function where different elements have same images. Okay, now moving on to the second type of function, that is an onto function. So I'll discuss it here. Second type of function is onto function. It is also having another name, surjective. This is also called as a surjective. These are the common terms now we are going to use. So again, a function f from x to y is said to be onto function. Is said to be onto if every y belonging to y, that means if for every y belonging to y there exists x belonging to capital X such that f of x is equal to y. Right, that means every element in your set y will have pre-image, as simple as that, right? Because it is saying that for every y, you are traveling back, for every y belonging to y there exists x belong to x such that f of x equal to y. So how it will be looking pictorically? Suppose if I have a set x, if I have a set y, what does it say here? Every element, okay, anyhow you can draw every element. Suppose if I put one more here, every element in my set y should be having pre-image, or I can say all elements of my set y should be having pre-images, or other words I should say that all elements of y should be images of some elements of your function under your set x. Is that clear? So you can see that every element here, onto means traveling back, every element is having a pre-image. Okay, so this is an example of an onto function. Okay, now exactly complementary to this, we have called one function called as into function. What do you mean by into function? Exactly opposite of it. Exactly opposite of it means what? There will be one element. Okay, there will be one element. For example, this way. Okay, there will be one element in your set y such that it does not have a pre-image. It can happen. No, it is not necessary that all your elements of your set y will have pre-image. There can be some element which is left out and which does not have a pre-image, right? So this kind of function is called as an into function. Okay, so let me just revise this concept of 1 1 again. 1 1 means every element in your set x has exactly one element in your set y. Okay, then it will be 1 1, otherwise it will be called as a many one function. Now what is onto function? Onto function says that every element of your set y should have a pre-image. That means there should not be any element left out in your set y. Every one of them should be having a pre-image. Okay, now what is the definition of an into function? Into function says that if there is an element which does not have a pre-image, then it is an into function. Now coming on to the last type, that is nothing but bijective function. Bijective function is very simple. Bijective function means when your function is 1 1 and onto, that means your given function, if your given function is 1 1 and onto, okay, if your given function is 1 1 and onto, then that function is said to be a bijective function. Okay, bijective function. Now we have to learn some results related to your functions. Okay, I'll just revise the highlight some important functions. Okay, so there are three types of functions, children. One is one function. You have one is one function. You have onto function, and you have bijective function. Okay, now one important highlight of this, some important results or some highlights are, children. If your range of your function f, okay, for a function defined from x to y, if your range of your function f happens to be your set y, then your function is said to be onto. Isn't it correct? Yes, range of f equal to y means what? Range of f and y. Range of f equal to y means what, children? Just let us come back. Range of f equal to y means every element, okay, every element in your set B has pre-images. So, every element in B, if I am having pre-images, that means I am covering the entire set B. That means my entire set B itself is my entire set, that is your codomain itself is my range. Is that clear? So it's a very important result. Often we use this result for finding whether a function is onto, or indirectly to find whether a function is bijective or not. That means we are just checking that all the elements of your codomain, happens to be range of f, or in other words, every element coming from y has a pre-image under your set x. The first one. Now the second result says that if f and g are one function, right? If f and g are one function, then f plus g need not be 1, right? F plus g need not be 1 function. That means what? If I have two functions f and g and 1, it says that f plus g, you cannot say anything about f plus g, because for example, if I take fx as sin x and if I take gx as cos x, you can very well see that your sin x and cos x, if you add it, the resultant function is not going to be 1. Exactly. You can never guarantee your f and g are 1, then f plus g will be 1. Similarly, if I have my function f and g as onto function, f and g are onto, then f plus g should be onto. This cannot be guaranteed, children, because it will depend upon how you are set. It may or may not be, but in general we know that if one thing is violated, the entire situation becomes wrong, right? So the second result says that if f and g are 1, f plus g need not be 1. We have to check it definitely. Similarly, if f and g are onto, then also you cannot decide whether f plus g has to be onto function, or it need not be compulsorily an onto function. Now the next one is, suppose if I have a finite set M. If I have a finite set M, finite set M means I have a set M which has finite number of elements. That means I have M number of elements, and it is having it is forming a function. It is forming a function to itself. It's forming a function to itself. For example, I have a set function f(a). Okay, suppose if I have a function f, it is a function on a set A, and A has m elements. So there are some important results based on it, which says that total number of 1 functions, from a finite set of m elements to itself is going to be m factorial. Why? Because if I have m elements here, children, I have m elements here, so my first element, if I am looking here, it will have m options, right? It will have m options. Second element will have m minus 1 option. Third element here will have m minus 2 option. Fourth element will have m minus 3 option. So that is nothing but the definition of factorial, right? So total number of 1 function is m factorial. Similarly, total number of onto functions, we have the same number of choices, it is also going to be m factorial. Onto function, because onto function says that every element should be having some pre-image, right? Every element in your set B definitely should be having some pre-image. So for in other words, for deciding an element in your set A, that what should be the image in set, what should be its image in set B, it has M option. The first element have M option, the second element can have M-1, M-2, M-3 and so on. So it will be again M factorial. The third one, now because 1 and onto function is M factorial, the number of bijections, okay, I'm going to use bijective functions, it's a short form for that. Number of bijections possible is also from a finite set M to itself will be again M factorial, because bijection is mainly defined on 1 and onto. Okay, so today we have studied very important topic, children. That is, what is the definition of function, what are the terms related to function, then you have 1, onto and bijective function, and then at the last you have some important results. Okay, you have to be very thorough with injective function. So injective function, you have to just familiarize yourself with the definition of function, injective function and surjective function, then all problems are through. So the definition of function says that every element of your set A should have one and only one image in set B. Okay, and how does it become injective? It becomes injective if every element has exactly one image. That means one element has two image. One element or two element cannot have two element. If they are having same image, then elements should be the same. Now what is the definition of onto function? Says that onto function guarantees that every element in your codomain should be having pre-image in your set A, or in your set domain, or every element of your domain should have the images, and it should cover all the images of your codomain. Or in short, you can say that range of F is equal to codomain. So next time when we come, children, we will solve problems on different types of functions and on functions. Thank you, children, for listening to me.